So first of all, let us start with our introduction to the data science part. Here are some of the common definitions. Before I go into the definitions of data science, let us first discuss about what are the different type of analysis which are there that we do, that we perform, and the where does this particular data science fit in itself. So we are starting from first the types of data analytics that we can use. Data analytics. First type of analytics. Descriptive analytics. First one is descriptive analytics. Let us talk about that. So the type of so the first question that comes into our mind when we see the data set is what we can do with the data set part. When you get the data, you can perform some analysis, right? That's what the data analytics is all about in short. What you wanted to achieve from that defines the types of analytics. First one starts with descriptive analytics. Descriptive analytics gives you the answer of what has happened. This gives you the answer about what has happened. In this case, what you do is you take the help of statistics. You take the help of statistics. For example, your mean, median, mode. Some hypothesis, etc. That means it's full of math thing that you apply. You full of statistics that you apply to the data part, and you get the hidden details from the data, and you finally find the answer of what has happened. Here, our motive as a data scientist is to analyze and find the trend, the pattern, and proving some hypothesis. So our main motive through the descriptive analytics is that we will try to find out that what has happened in the past. We will try to find the answer for that. These are some of your historical data. Historical data means the data which has already been happened, and we have these data available to us, and we wanted to use this data in a more informative way by using statistics, by using programming, by using visualization techniques to get the answer of simple thing that what has happened. So that's the question we will try to answer in case of the first type of analytics, which is descriptive. For instance, let's take an example here. Example will be, I wanted to prove that the weekend sales of movie tickets are more than weekdays. I wanted to prove this, right? So when I wanted to prove it, I need to take the help of some sort of a statistics. Maybe I can compare the average ticket price, average ticket sold in the weekend versus average ticket sold in the weekdays. That could be one of the reasons, right, through which we can prove that whether the weekend sales are more than or greater than the weekdays or not. So this is the type of analysis you do in case of descriptive analytics. Could be some more examples we can take. For instance, you can take like subway example, and you wanted to compare the revenue generated. So my next hypothesis will be for the subway. The next hypothesis that I wanted to prove here is that the revenue in store near commercial space is greater than residential space or residential area. Okay, this is the type of analysis that we are trying to prove here. Historical data is like the data that has been already happened in the past. This is like suppose past 2 years of transaction data we have with us from the subway. So what is this last 2 years data? Last 2 year data is historical data. Okay, so that's the type of analysis we do in descriptive analytics. So as a data scientist, you can do this type of analysis. Okay, and next part number 2 is predictive analytics. In this case, we are not applying any machine learning algorithms. If you know about those topics, here our work will be done through simple statistics and the various. Okay, at times you can also apply EDA, stands for exploratory data analysis. For the time being, let's avoid this word and let's settle down for visualization. Through that also you can try to answer about the question of the trend, the pattern, you can study about it. Next is predictive analytics. In case of predictive analytics, this is the type of analytics that will try to answer Here we will try to answer about what will happen in future. This is the type of analytics that has ability to answer questions like what might happen. So you are trying to predict. By looking into the data, you will try to answer the question of, you will try to make prediction for the future. That's what our motive is through this particular type of analytics. Second type of analytics. Now in this case, how you will differentiate here between the both? The question. The question itself is the difference. In the previous one, we were just using the statistics to answer the question, to analyze the data that is available to us. Here, we will use the data to predict what will happen in future. The word is prediction. Predicting, or the word is forecast. What is the difference between predict and forecast? Let's try to understand it. Forecast means when you are trying to predict on the basis of time. When you predict based on time, okay, like date. Like for example, you predict the weather. You don't say you forecast the weather. Sorry, forecasting the weather is done on the basis of time. So forecasting the weather. As I said, guys, please keep your questions. Once I am done with the topic, then ask it. It will be better. Otherwise, many of your questions will be missed. I'm already taking the topic, so I can't do both the things at a time. If anything is not clear, you'll get the time in the end. After the topic finishes, you can ask your questions then. It will be better. That is a learning practice we can develop. Alright, so here we are trying to use some statistical model or forecasting techniques. So both are two different things. One gives the answer for prediction, and one is a simple prediction here. One will be forecasting, which will be kind of a solution for date based or time based prediction. Like when we say that predict the price of the house, predict the price of the house. This is not dependent on date or time, right? This is dependent on the characteristics of the house, the location. So you can say latitude, longitude, then bedrooms, number of bedrooms, right? The area, total square feet, how much area of the house is there, right? Etc. Location is important, so latitude, longitude, etc. Whereas in this case, when we say forecast, we try to forecast it like share price forecasting. Share price forecasting. In this case, we are trying to forecast with respect to the date, on the basis of the date. That's why this technique is called as forecasting, because you are predicting it on the basis of the date, on the given date, what will be the value. Here it's not like that. Okay, so on the basis of the existing data, you make prediction. Make prediction on the basis of existing data. Okay. So as we all know, predictive analytics comes under the topic of your machine learning. So remember this part, that here your algorithms will be used, your machine learning algorithms will be used, and that's a different topic. That's all different topic that has nothing to do with our data. I mean, they are connected, but the topic is totally different. Here we have to learn about some of the details about what are the different type of learnings are there, what are the different type of machine learning algorithms are available to us on the basis of the data set. Third one is your prescriptive analytics. Third one is your prescriptive one. So let's take that. Prescriptive is very less used. Prescriptive analytics. In case of prescriptive analytics, we are trying to actually use those algorithms which will help us to find the question for what should have been done. It's a solution builder. This is the type of analytics in which you are trying to find these, you are trying to build a solution. In the first one, you have understood the data. Then in the second one, you have made a predictive model. And the third one is your solution builder to optimize this is the type of problem statement where we expect the data scientist or the statisticians to find the solution, to find the optimized solution here. So this is type of analytics that is used to advise the users on possible outcome and answer the question what should have been done. That's the answer we are looking for. This is a totally a different type of solution. Okay, you can call it as a business solution that you will develop on the previous two results, on the previous two steps of your predictive and your descriptive. The prescriptive is your solution builder. Okay. All right. So this is very less used. I mean, even if you will not use it on a very high level. Okay, this is a very high level thing. So, I mean, for a time being, you can keep this part aside. This is not important. Like, I'll give you some examples. Suppose sometimes I can give you one example here. Suppose there has been, I mean, a particular location is there. In that place, it's a tourist destination, by the way. Okay, so in that place, there, I mean, various tourist destinations are there where the bus starts from a place and it goes to different stops. All the tourist destination, there is stops, and then it continue in a particular circle. Okay, the bus starts from a particular location, then it goes to next stop, then it goes to next stop, and then it goes in and around that particular location of your particular tourist spot, whichever. I mean, let's take XYZ location here. Okay, so the point is, like, this is the bus route, current bus route is there, and government is looking to optimize the route. so that they can cover up the maximum spots, as well as they will able to gain they can increase the efficiency of this bus route. Okay, this could be like on the basis of they wanted to increase their revenue and so on. So there could be many here which could use your different type of optimization algorithms, and that's the type of solution you can build. I'm just giving you one example so that you can understand. So maybe the suggestions could be like some of the routes should have been eliminated, etc., etc. Just give me a minute. So this is how the things work here in this part. Now I'll take your questions here. This is all your three things that we have discussed, which include descriptive. So first, any question about the descriptive part? Any questions about the descriptive one? What is hypothesis? Hypothesis is particularly like I have taken here. Just a second. Okay, so I was saying like the hypothesis is very simple thing that suppose you wanted to prove some, you have read the data, right? You have read the data, you have studied the data. Now on the basis of the study data, you wanted to do some research. Okay, and during the research, you will make some assumptions. You make some assumptions about the data. That is called as hypothesis. In case of statistics, we make some assumptions. Like my assumption is, what is the first assumption? Weekend sales of the movie ticket are more than the weekdays. That's my assumption, right? So I need to use this data to prove, maybe I will use some movie data to prove that my weekend sales, my assumption which was there, whether it is correct or not. So on the basis of the data, I will make the assumption and I will test on the data whether my assumption holds true or not. So as a hypothesis testing is just using the statistics where you test an assumption on the basis of your data set. So you watch the data and then you decide certain statistical hypothesis. Like in this case of this, we have used certain other data and our assumption was there. Maybe our assumption will be true, or my assumption will be failed to, yeah, correct. No, no, no. Right now, I'm not going to give you any example about null and alternative. How can I give you the statement like that right now? We can understand it without that as well. All right, so that's how my hypothesis definitions are. Hopefully, I've understood it now. The second question which I can see here is about data mining. Like now, data mining is, you can say, a shorter version of the machine learning. It also uses certain algorithms, and its process is to basically, okay, let me take the data mining definitions. So its main purpose is to see through large data set and identify the pattern. In this case, we will mostly focus on identify the hidden pattern and, yeah, hidden pattern grouping of data. It's all about the using the data and finding some good insights from this. Again, you can see that by looking into the data, you want able to answer the questions like whether there is a relationship between the data or not, between two, let's say two columns. Two different columns are there. Okay, so you collect a large data and then you try to solve some business problems. So that could be also there, solve the business problem. Like suppose I wanted to group here my two customers. It's called as customer profiling. On basis of spends on shopping app. You can take any application, okay, any e-commerce website, and they are particularly doing, they are running some data mining to group you in maybe two groups are there or three groups are there. Think about it. The one which are like high spends and which are like low spends. I'm just giving you some example, okay, so that you can understand. Now we looking into the data set, you will not able to identify that which all group goes to the high spend category and low spend category. For that you have to apply some statistics. So that's what the data mining does. You collect a large data set and you try to solve some business problems. Like this was one of the business problem that we did. Like, okay, so on the basis of the spends, like how much particular things you spend in a year or in a month, on the basis of that, the e-commerce website will be putting them into certain category which will be not known to you. So many times we have discussed already about what is historical data. Historical data, what it is, we just discussed. Historical data means whichever has happened in the past. Data collected from past, which has already happened. Like last 5 years, census data, that has already happened. The previous data that is known to us, correct? Okay, so next part is predictive analytics. Predictive analytics was quite easy. Here in this case, you will make prediction on the basis of the available data. Data aggregation is about majorly doing the summation and all. When you perform summation, count, max, min, average, that's called as aggregation. Prescriptive analytics. Prescriptive analytics is using certain algorithms to perform some business solution. Like the example was to optimize a bus route. That was the example we have taken. Otherwise, just think about it. This is about to give the cure of the given problem statement. This is to, that is your suggestion. Suppose your goal is to increase the revenue of company in a certain, you wanted to increase the number of revenue of the company up by 7%. So what are the cure you will provide here? Correct? So that will be your 7% up sale. Suppose that's the problem statement has been given to you. So what's the solution you will build? So you will try to build a solution that could achieve, that could help the company to find So that's your prescriptive analytics. Forecasting technique is when you are trying to make prediction on the basis of date. I have already given the examples like share price forecasting. How does we predict the shares? We predict on the basis of that on the given date what will be the share price. Similarly, we forecast the weather on the basis of time. Right? You write a date and time. That's why they are called as forecast. Make prediction on the basis of. Prescriptive is more of like a problem solution rather than making prediction. This is a solution for builder. So any problem you have, you build a solution around it. Alright, so that's it. This is all about our 3 examples. Now we'll go back to our data science part. So now by looking into this definitions, you can your part is that you will try to fit into the 3 things that we discussed just now. So let's first take the definition, then I'll ask you question. So the point is here that we use here some of the common definition of data science. Number 1, data science is a powerful new approach to make discoveries from the data set. So we try to find the hidden pattern from the data set that making the discoveries. So let's start with some of the common definitions here. First of all, the data science is powerful new approach for making discoveries. Other term is it is an automated way to analyze enormous amount of data and extract information from it. And this is a new discipline that combines the aspects of statistics, mathematics, programming, data visualization, and turn the data into an information. Again, here the data will be historical data. And using the historical data which has happened already in the past, you will convert this data into a nice informative part. You try to find the historical data, you use the historical data and you turn the data into the information, which include hidden details. Okay. The plenty of statistics scope will be there in this case. So using statistics, we'll try to answer the question of what? So out of the 3 examples, where the data science will fit in most? First, second or third? Data science fits in where? First part, second part, third part. Most closely, the data science is descriptive analytics, which also means that data science is a prerequisite before you apply the later two. Descriptive analytics is something which will be a prerequisite for predictive as well as prescriptive. Now there is no where it is prescriptive. I can't see like how you all have made this related to what should have been done. We are not finding the solution. We are finding we are using the data to actually know what has happened first. That's where from that's what the data science is all about. And as I said, this descriptive analytics becomes your prerequisite for predictive as well as your prescriptive. Prescriptive is your business solution. We are not using the statistics anywhere here. Okay, we are using the optimization algorithms, which will be particularly giving us the business solutions. Like I just said, I wanted to increase the revenue of the company. So what are the solutions we should look for? That's not a data science thing at the beginning. This is the end game. This is the end thing which majorly is been taken care by the business group, business people, business team, not the statistician, not your data scientist teams, especially the beginners one. Like in this case, my goal was that there is a given bus route to you and the government want you to find some solution that will help us to optimize this bus route, right, which will increase the efficiency. So many solutions could be there, like you can try to avoid certain stopping the bus, every buses at every stop. Maybe there could be alternative bus will stop at alternative bus routes that will improve the optimization, etc., etc. So these suggestions that you provide are the challenges of prescriptive analytics. That's not your data science. Data science finishes here in first two. Majorly the first part is data science. So that's what the definition says. Now anyway, no problem. As we will progress ahead, you will be able to understand it as we will progress all these parts. Now the components of the data science. When you combine domain expertise, let's try to take some examples which will give you more clarity about what exactly the data science is. So when we talk about data science, you should have a domain expertise about the data. That is important. If you have the domain expertise about the data, then you can better use that data and you can find the better solutions in terms of by using the data science, you will be much more efficient. Way of using the data science will be that you should know the data well. So we have a different types of data which will be available, right? Somebody will be from the medical background, so they will be having a better knowledge of the medical data, right? The medical images will be there or medical records will be there. Similarly, we'll be having records like financial. Suppose you wanted to perform some financial analysis, so you'll be having some financial data. Then you will be having some data related to shares. Okay, HR data will be there, like HR employee data. So different domains data will be available to us. Let us try to understand the type of data. Okay, so using this type of data, what you do is you apply your domain expertise using some of the mathematical or statistical models, or you do the analysis, or you use some scientific tools and methods. That's one thing. This is the domain expertise part, which include your details about The statistical knowledge is important, as I said. If you have the statistical knowledge, it will be a very important part. Okay, then applying the scientific tools and methods becomes quite easy. If you don't understand statistics, then you might not able to apply it. Use of technology, which includes Python language, various operating systems, application design, library, data processing tools. Let's try to have a quite a good discussion about one by one. So data scientists, they particularly, so let's look into the each component of your data science separately now. The first component is domain expertise and your scientific methods. Data scientists should also be domain expert, as they need to have knowledge, good knowledge of the data, so that they can discover the right pattern in them. Traditionally, domain expertise like scientists and statisticians collect and analyze the data in a laboratory, in a closed, controlled environment. When the data and the data was then subject to some relevant laws or mathematical and statistical models to analyze the data set and derive the relevant information from it. For instance, they can use model to calculate. So we have got some mathematical and statistical models. What are the basic mathematical and statistical models we can use? Could be central tendency. What is central tendency? Knowing the central tendency about the data, that is, what is the mean, median, mode of data set, like then standard deviation. If you know about these terms, it's okay. Otherwise, don't worry. We will discuss that as well. So we have got here mean, median, and mode. These are your three central tendencies. Mean means average. Median means the central. This is your central value. The middle term. Mode means most frequent. Etc. So mean, median, mode, that's your central tendency. And this is the type of many more. I mean, there are many other terminologies that you should be aware about first. That comes under your domain knowledge, apart from the data knowledge part. So mode is your highly repetitive, the most frequent value, the most frequent data. Median, the middle term, and mean, the average. So what you do is you use the data and you then use these mathematical and statistical models to perform the analysis over the data. That comes under your domain knowledge. So as a data scientist, as a statistician, we expect that you should be good in a bit of maths, will be always there, and that's a by default part of your data science as well as your machine learning, both. Okay, so data analysis, we have just discussed about it already. What are the different type of analysis are there? Descriptive, predictive, prescriptive, right? As I said, in the prescriptive, we suggest the actions, suggestions on the basis of the collected, on the basis of your goal that you wanted to achieve from the data set. This is about making prediction. Simple it is. And when we say we wanted to make prediction, what we'll be using here? Say it. What will be using in this? What will be using in case of predictive analytics? Let me check. No, what comes under the predictive analytics? Just like I said here, the forecast part, the machine learning algorithms, correct. Forecast and your machine learning algorithms. That comes under predictive analytics. Okay. And descriptive is your study of the data and you use your statistical analysis. And in in prescriptive, it's about your business solution that you build. Okay, so that's your scientific method that we should know. As a beginner, you don't have to worry about it. All we will discuss one by one, starting from Python. Okay, so now we can discuss about the next phase, which is your use of technology. Without the presence of the technology, we cannot perform a better data processing and analytics. Like model tools and technologies are there to us, available to us, that made our data processing and analytics faster and more efficient. That's one of the good things. Due to the presence of the technology, we all can learn about these topics. Okay, first of all, the importance of Python language. Okay, so let's discuss about it. Data analytics. Now we can access the tools and technologies that processes the data and extract the information that we need. For instance, there are data processing tools for your data preparation part, like we have got data processing tools, which is particularly related to a topic called as data wrangling. In cut short, what is data wrangling that we do here is, we try to prepare the data, like we try to clean the data in this case. Cleansing you do in this. So maybe your data set will be having a lot of unwanted elements, right? Unknown elements will be there. Okay, unwanted elements will be there. You will try to treat them. It's about treating the unknown and unwanted data. That's what, in short, data wrangling is all about. Okay, yeah, it could be checking null values, checking missing values. Okay, let's not use those terms right now. Let's understand it in a layman's term or use some basic terminology here, like unknown and unwanted values. Our motive is to properly clean the data and prepare it using the tools that are available to us. Okay, so Python provides us a very vast amount of libraries that we will discuss as we will be progressing ahead. So we'll use those terms, those libraries, to properly do these things that I have mentioned here. So libraries are there, plenty of a good large amount of libraries are there. Are there from Python. Okay. Application design, operating system. So yeah, these are common things. Due to the presence of operating system, application design, All these things are available to us. So you see the data, you correct the data first from the raw form, and then you extract the information. Otherwise, what will happen here is, so hopefully you have understood what data science is all about. Let me first ask about it, whether you have understood what exactly data science is. And so just think about it, that you have a historical data and you wanted to extract the information from it. And method could be many, technology could be many, and you will simply do here what is, you will use the data and you will get to know about the hidden details which through looking into the data is impossible for a human. So you use the statistics and you use the data libraries from Python, and then you extract the information from there. That's what the data science is all about, in short. And that's what we'll be doing in our course. Why Python is most used tool? Because it is open source. We can customize it. There are the number of libraries that are available are more. It has got huge, large amount of community, which is not, which is, I mean, the most in the world, you will say, as compared to the other programming languages. That's why this is one of these more. In order to design an application, we need the data. Yeah, that's what. Python is easy to apply, correct? Now let's talk about the next part. Let's take some of the examples now. Data processing and analytics. These technologies help the data scientists to build and train machine learning algorithms. Now remember this part. Data science you use to prepare the data and extract the information by using various libraries, and then you take the output from this. That means after this you convert the data. Just imagine like this, that you have got a raw data. Raw data means which is uncleaned, unformatted, and you convert them into a nice clean data set. If you perform any analysis on this, if you perform any analysis on this raw data, that will not be any great help, because the information that you get from this is not proper. It will be a false result. What you do is you first convert them into clean, and then you apply the data science methodologies. Okay, like your machine learning or visualization, anything like that, or data wrangling. And then you go into this process of building the model of machine learning. Then you manipulate the data with technology, etc., etc. Okay, you build the data, you build a model after your data science part gets finishes. So that's why after this I said that you can go for the machine learning course. Before machine learning, this part should have been understood and clear to you, like the data science part. Applications, this is important, because through this you will able to understand what exactly the data science applications are in a real world. Okay, so let's study about it quickly. Different sectors using data science. It includes things like your social network platform, search engines, healthcare, finance, public sector. We take the information from this, we extract the information from these various sectors. These are all your data source for us. Once we know about this data, We extract the information from these. All right. So we now know the skills that data scientists should have. Now let's see the applications of the data science in different sectors. Social network platforms such as Google, Yahoo, Facebook, and so on collect a lot of data every day, which is why they are which is why they have what is going on, Samek? Will you please stop doing it? So, which is why they have got some of the most advanced data centers spread across the data. They have got a huge data set which are stored under various data centers. Having data centers all over the world, that is why not just this does not only help the US but other companies as well to serve their international customers better and faster without any network latency. They also help them deal efficiently with enormous amount of data, which is called as your big data. And their team of data scientists analyze all these raw data with the help of modern algorithms, data science, statistics, visualization to turn the data into the information. So our main motive is take the data from this, feed them into the various algorithms. The technology part will be here, which include the statistics, visualization, and our motive is to convert this data into a good information, okay? But what we will do with this information? I mean, what is our goal? Our goal is to use this information to convert this information into services, products, by understanding the need of the customers. Okay, like if you will compare the Facebook and Instagram, LinkedIn, they all have a huge data centers, and these data is shared across multiple companies. These data is shared across the multiple companies. What they do with this data, they study the data well, and then they apply the technology coming up from the various Python libraries, data science, machine learning, anything, any one of the three type of analytics that we studied. And their motive is to convert this raw data into a nice information, and then using that information we will study the behavior of the customer, and will be either improvising in our particular social media platforms, or maybe some other company can use this data to make some product, and or make better solution provider services for the same. So that's how it is connected. Let's have much more detailed information as we'll be progressing ahead. So these are the different example. Number one, let's see the first how these product and services works, and we will start from the LinkedIn. So till here everything is clear. Before I start with this, everything is clear. Can I have a quick yes in the chat? Hopefully I've understood all these few topics that we discussed. These are all okay. So you can drop yes in the chat if you have studied it. Okay, thank you so much. Let's move to the next first example. So first example begins from the social network platform LinkedIn. Okay, I'm sure many of you will be already aware about what is LinkedIn is. So LinkedIn has got details regarding. So this is where you can see, like, let us suppose that you are a data scientist based on this is the name of yours, John. For instance, let's assume this. So John is data scientist based in New York. So it's quite likely that you'd like to join a group or build connection with the people related to data science in NYC. So by analyzing the profile, the type of group this person is already part of it, the location, and the connections. All right. Now, what LinkedIn does with the help of the data science is that it looks at your profile, the type of post that you share or like or comment. On the basis of that, and the city that you come from, the background of yours is also important, and the people you are connected to, and the groups that you belong to. Then it matches all that information with its own database to provide you with the information that is more relevant or most relevant to you. So that's the service that the LinkedIn will provide you. Like when you will go to the home page and you will see the relevant post that is coming up from its database, from the LinkedIn database. It will provide you the it will provide you the services. And what all services include? It includes services like the news update, the new connections, like suggestions, job posting, etc. These all comes in by taking the information that you have, by tracking your activity and by tracking your information that you have made it available on the LinkedIn. Whatever you have shared, according to that. So let's say, for example, based on what LinkedIn is learning from its site, it has created a new education company. By tracking all these, the LinkedIn has created a new education company which is named as lynda.com. It is an example of your data product. Again, by analyzing the requirement, like if you will see, there has been tremendous growth of the data, especially the digital universe has increased from past few years, past, let us say, 7 or 8 years. There is an exponential increase in the data, and to manage this data in different industry sectors, there are team of data scientists. So definitely there will be a requirement of people who are enthusiastic and who wanted to learn new technology. They have been, so every post which is going on, so what type of post that you share or you like, on the basis of that and the type of things that you are doing, the type of job postings which are coming, according to that, the requirements already get updated on, and the new products will be always coming up. So suppose right now there is a trend of data scientists, and maybe in upcoming few years there will be a trend of blockchain, okay, or maybe some other technology. So like that, the things will keep on changing, and that's all happen with the help of data analysis. So data analysis has made our things quite easy, right? That's what the main point was from this example. Hopefully you have understood this part, like how social media network uses your data to provide you two things, the digital services and data product. Now similarly, you can use the same type of thing. Just a minute. So I was also talking about, like, suppose you are watching, you are using some other social media networks like Facebook. So maybe in the Facebook, the type of videos that you watch, or maybe the more relevant will be your YouTube. The type of content that you watch, you can control it, right? You have the option to control the things. You watch the type of, you subscribe to certain channels, and the channel, the videos that is getting uploaded there will be sent to you, or the type of videos that you watch, the type of content that you watch from a specific channel, even if you have not subscribed to that channel, if any new videos is uploaded on that, you get the you can watch it from your home page. You get the notification if you have subscribed and you have pressed that bell button. So these are the type of things which are again coming up as a services by using the type of data, the type of videos that you watch, right? So every video has got the hashtags. Then age also will be your important thing. Location, your language, excuse me, language, location, age, hashtags that you watch, then yeah, etc. So type of things are used there in your YouTube channel, and then again it is giving you the same services, the type of content that you watch, called as recommendations. In that case, it is called as recommendations. Next important example of your data science. Using data science as in your search engines. So we all know Google search engine, right? So let's look at some of the examples of Google search engine here. Google search engine has got most unique search engine algorithm, which allows machine learning models to provide relevant recommendation or search recommendations here, even as the user type in his or her query. So you write like data, and you get to see the recommendations like data, then data science, data scientist, salary, structures, excuse me. So yeah, we are talking about here when you write data science. Now it depends upon if you are frequently using these terms, then only that you will get the type of recommendation that you see. All right. Otherwise, you can get some different recommendations as well. This will depend upon various factors. So what are the different influencing factors here are available on your right hand side? Number one, query volume. The first one is your query volume. The Google's machine learning algorithm identify unique and verifiable users that search for any particular keyword on the web. Based on it, it builds a query volume for all the queries which are being searched by the user. Verifiable users means somebody who has been already available and using the Google services. So unique and verifiable users, their data will be scanned, like what type of query has been searched, and then according to that this volume will be created. Like for example, right now if you will see, the people will be searching for, like now it has been on the lower side, but still COVID cases in, then it will come to your country, like your country name, COVID cases in, or maybe your your city names, correct? You get the country names, you get the city names, etc. So that's where you can think about it. The query volume, yes, query volume will be your example for your most searched words. This will be your most searched words. Most searched words. This answer could be easily given by your query volume. Second important thing, the factor that affects the machine learning algorithms result, the suggestions or the recommendations that you get is the geographical locations. So if somebody is available in New York or in US, if he is typing some initial letters, he might get some different search recommendations than you. All right. So geographical locations do affect how it works actually. So what does the Google does is here is that it tags the query, right? The keyword that is getting searched, it tags the query with the location. Whenever a new query or a query is getting generated, this will be tagged to the location and it will be added to the database again, the huge database of Google. There all these informations will be stored. The query and its relevant geographical location. So this makes actually a query volume location specific as well. You will be having a query volume to a location specific. It is a very important feature because this allows Google to provide relevant search recommendation to its user based on his or her location. Next part is the algorithms consider the actual keyword and phrases that the user types in. It takes up those keywords and crawls the web looking for similar instances. That's another thing. Keyword or phrase matches on the web. Basically, it scans their web part, the content, and then gives the relevant information. Sometimes you write wrong keyword as well, right? So that's talking about that. The algorithms also try to filter or scrub out the inappropriate content, which includes violent content, terrorism related content, hate speeches, legal cases are scrubbed out from the search recommendations. So in this case, scrubbing out means this is a kind of a filter for content like terrorism, violent content, okay, hate speech, etc. That's my example number second. Okay, so what are we covering? We just covered here social network platform, done how social network uses the data as an information and it provides us the digital services and data products. Similarly, the search engines uses our information. So when it asks for the location by Google, this is the type of thing that it try to justify its location. Obviously, the other things are also there, like its ads and all, but this is also the part of their query volume part. Okay. Third example, this is from the medical sector. So first two examples are over. Let's try to understand the third example. Third example is related to your health care. That's your smartwatch, quite an important device. Okay. So today, even the healthcare industry is beginning to tap into various applications of data science. Okay, there are various applications that you will see in around you as a product. It's available. To understand, let's look into this example here of wearable devices. These devices have got biometric sensors which monitors your various biometric details like the health pulse rate, correct, number of steps, right, your kind of heart rate, heartbeat, etc. Okay, we all know what are the details we get to where it stores. Now it is trying to get to know about the type of information that it uses and then how it converts into a nice engagement board, which is your app, right? Whenever you get connected, you get connected through Bluetooth, and then you can monitor, or even on the watch you can see the settings, right? So everything is in the UI form. That's your final UI, which shows your information. But this journey from tracking the data through the sensors to your engagement board, the app, where the user gets the information, this journey starts from using another terminology, another technology called as Internet of Things. This was another buzzword, just like right now data analytics and data science and data engineering are. In back 20 in around 2017-18, IoT, and even till 2020 it was very much popularly, it was having a lot of buzz around it. People wanted to learn about the IoT things. Okay, the reason was that it was basically, its main idea was to communicate between machines. We call it as M2M, from one machine to another machine. Like this watch is a machine, and this mobile is also a machine, right? So that's the type of communication we are trying to study through this term called as Internet of Things. The main idea was to control everything through the wireless communication and through the apps, through the applications, through the internet. Like right now, I'm at my office. Let's assume I wanted to know what is the energy consumption at my office and at my home. I can do it with the help of IoT by connecting my entire home appliances with the various sensors, and I'll monitor the energy consumption, and I can monitor it wirelessly with the help of internet by living in a different location. So major idea was that of the IoT was this. Hopefully I've understood it. Now let's back to our example. So the healthcare industry in the beginning, these devices have got biometric sensors and had a built-in processor to gather the data from your body when you're wearing them. They transmit this data, which is called as your biometric data, via IoT gateway, and then it is getting stored in some infrastructure. Let's say, just understand this as your data warehouse, where this data will go, as it has to collect hundreds and thousands of data points. By looking into the data, applying the data analytics tools, you can convert this into the various things. Okay, this could be also used, this information could be also used by the various doctors to provide you some personalized solution, right? If you are going through some health problems, it will provide you some solution as well. It can prescribe you some medicine, or it can prescribe you uh, some change in your regular habits, okay, or change in your food. So quite a important device in nowadays as per the current. Next is your finance. So here is your financial data. Now, one example could be in the financial could be the use of loan manager. So making the things easy here in the finance sector, we can again call our data scientist team and make the functions more efficiently. So one example is this. Let us suppose a person applies for a loan. The loan manager submit the application to the enterprise infrastructure for processing. So here is your loan appliant, which will upload its let's say car loan or house loan or personal loan into the loan application portal. Now we know that there is an important factors here which include age, income, then most important is credit score, or which is also called as your CIBIL score, etc. By putting up all these into the loan application portal, the data transfers to the enterprise infrastructure again, the entire database, then apply the data analytics. It goes through the data analytics, and there you will be having the presence of data science. Then from the data analytics, it goes to the engagement board, and it generates the credit report, the credit history, like if this person has taken any loan earlier, etc., etc. These details are been approved here. These details have been displayed here, and then what is the amount that can be approved maximum, and the risk involvement, risk of repayment, and then it's up to the human, it's up to the manager whether he wanted to whether he wanted to approve the loan or wanted to deny it. That's how the financial, that's how the data science could be used in a finance. Also, this could be used for the for stopping the credit card fraud detection. Let me give you one example related to this. Okay, I don't know whether you have experienced anything like this, but this is my personal experience which I faced. So it's a story of back a few years back. I mean, it's been quite 4 5 years back. So I was using debit card at a certain remote location. Okay, where my presence was almost like negligible to bank. So I wanted to make some transaction here, and my transaction got failed. And also at the same time, my card got blocked because of security reason. So this type of security has been provided to you. If you are, I mean, this could be available to you in terms of, by default, these are always on. So suppose you are living in a certain city and you go to some other location and you try to make a transaction, okay, then there is a chance that your card can get blocked because of the security reasons, and this will happen automatically. It won't ask you. So maybe there will be improvement. Maybe it will ask you or give you a call. But this is also the example where I faced like how this security things work to stop the fraudulent transaction. Okay, so that's how the data science helps the banking sector the finance sector as well. All right. Now this is all happen. This all data science things happens. So all examples are clear. Any questions? Please go ahead. I'll discuss the last example. All these examples are clear. Any questions here? This part. You can drop yes in the chat to confirm. Okay then, so we will continue rest of the things after the break. If there are no questions, then it's time that let's take a break here now. As so after the break, we will discuss about the libraries and all. And let's see, so few more theoretical terms which are there. And after this, I think 4 or 5 slides will be there more. And then we will take some MCQs and then we can start with some real stuff, the practical stuff, maybe starting from Python. Okay, so all these after the break, let's go for that. Okay, so poll is on. Now I'll start after 15 minutes. Yes, the break will be for 15 minutes. Thank you all. We'll see you in next 15 minutes. I'll start the clock in 1 minute. Meanwhile, you can quickly participate in the poll. See you in next 15 minutes now. All right, so welcome back, everybody. Let's get started with our post-break session. All right, so before the break, we have taken our discussions about the examples about the different sectors we saw here, from social media platforms to search engine, healthcare, and finance. Now, there are certain data sets which are available from the government websites as well. You can call these are like public data sets. And one of the popular one is from data.gov. This is for US. You can take this data and you can perform the analysis on this related to various fields, various domains that include your government sectors data, that include your crime data, that include your census data, science and research data, energy consumption. You can also use, this data could be also, this is also available there about the airlines. You have the availability of the airlines data in this, quite a large data. There will be some in MBs, and you can use these airlines to about the US data, and you can do some insight to find top airlines, top airports, etc. So here are your details which you can use from the public domain, and you can use this data to again find a good insight about the data set, about the particular sector, and you can use this data to make the things better. Maybe you can develop some product, you can, or you can become a solution builder as well. So that's the motive through all this, that we will collect the data and we will use this data to convert the data into a much more insightful and meaningful, and we will use this data to uh, solve and build some solutions. Right, that's the entire summary of what we have discussed. All right, so hopefully everybody is back, right? Can I have a quick present in the chat so that I can know before I begin with our next topics? Okay. So here we go, the real challenge. Let's go to that part of real challenge here. So in case of this, our main motive is that, okay, so I just was giving about the government across the different countries are gradually sharing a large amount of data of various domains with the public. This kind of transparency makes the government seems more trustworthy. It provides the country the data that can be used to prepare itself for different type of issues like climate change. As I said, the issues of making the functionality of the airlines better, and like for example, you wanted to know that which all airlines are uh, in which of the airlines there is a possibility that it will have the highest frequency of number of flights getting cancelled. Okay, then busiest route. You can also try to analyze the delays, the average delay in a route. These type of analysis is important as a public to you. You can use this to prepare yourself. All right. It also helps these type of data which is getting transparent also encourage the people to create their own digital products and services, which might be the government might be not looking into it, but maybe a company or as an organization you can study something and you can look for building some solution. All right. If a problem comes into your point of notice. So we have got the data science public sector example done. Okay, some of the real challenges. Now you can see some of the types of data written here like RDBMS, CSV. Before this, we'll again go back to our whiteboard and we will study about the types of data first. It's quite important to study the types of data because that will help you to actually understand that, okay, these are the types of data that will be there. And using this type of data, you can make some decisions. So I'll start with first, even your mean, median, mode, that also depends upon the types of data as well. So there also it will be used. One important term is the type of data. Here we are talking about the type of data which is unstructured. Unstructured. Let us start with unstructured first. Or maybe, wait a second. Let's go to the structured, right? Structured. When we say that a data is structured, we are actually, we mean that, what is the meaning of a structured data set? Anybody? What is the meaning of a structured data set? Uniform, okay, organized data. Data will be arranged in a tabular format. Data will be arranged in a tabular format. You will be having rows and columns. And there is a fixed format that the data will be arranged in a rows and columns and tabular format. Example, data from the databases. Example of database, MySQL, very simple one which you might have studied in your schools. MySQL, or in case of colleges, you study it by the name of RDBMS. Or even if you don't understand these, just take the example of Excel sheet. The data that is available from the various databases, Oracle, DB, MySQL, any RDBMS, or your Google Sheet, Excel sheet, these are all called as your organized data. Every data is a table in a tabular format and you have a proper rows and columns. RDBMS, anyone full form? RDBMS example is MySQL. Example of RDBMS is MySQL. What is the full form, guys? Anyone? Relational Database Management System. Very well. Relational Database Management System. That's your structured data. Example. Okay. Just think about it. The data available in your databases, they are called as structured or Excel sheet. Example number 2, semi-structured. Now this is important because most of the data that as a data scientist you will be using will be semi-structured. Most of the data that you will be using, you'll come across will be semi-structured. Now in this case, the part is like every file is having its own format. So there are format. But there is no fixed format of the data. There are format, but there is no fixed format of the data. Okay? Like every file might have a different format. So we have to look for the different files which include your JSON format. JSON file format. JSON file format include things like ID. So data will be available in this format. In spite of rows and columns, we have got ID here. Let's write 1001. Then we have got name here, which include, let's say the name of the person is. Any name you can write. Okay, so maybe you can just say Yash. That's your name. Then another will be age. Let's say age is 23. Then vacation. Sorry, not vacation, location we can say, right? Location is, let's say, India. So the data format in this case is called as key and value. The data format is key and value. That's your semi-structured format. Number 1. So there are different file formats. Same data you can convert into an XML format, extended markup language, full form. Extended markup language. Oh, sorry, not extended, extensible, right? Not extended, extensible. Extensible markup language, XML format. Now, in this case, the data will be available, the records will be available in this form. Like, you'll have a row ID. Please don't post anything right now in the chat. The chat window is closed at my end. Let's say, same data now I'm presenting in a tab form. So your your column data will be available like this. Okay. So ID, the value. Similarly, you'll have another records as well, which include, let's say, name, same Yash. then age. So different data file will have a different format. This is another format of file. Which is called as your XML file. Extensible markup language, JSON file format. Okay. Most commonly used CSV file. Full form is comma separated values. Comma separated values. So all these different files comes under your semi-structured format. Every file will have a different format here and different file extension. This is a .csv file, this is a .json file format, this is a .xml file format. Okay, in case of CSV, the record will be available like this, like ID, comma, name, comma, age, comma, location, and you will have the values 1001. Yes, so everything is now available separated by comma, as you can see. That's your row number 1. This is your one record. This is also your one record, first record. Okay. Now let's see if you have got any questions here. Okay, these two file formats are clear through the examples. So your data records will be available like this, as I have written here, and you will have a dot format as well. Yeah, the correction is made, Mr. Ram. Thank you. Just saw your thing. Is JSON JSON first of all? Just now I've said like this is semi-structured, right? So how come neither of the two? Format is semi-structured. It is written here. There are format, but there is no fixed format of the data. So JSON, XML, CSV, everything is under semi-structured. Structured was only one, which was data from the databases. Now unstructured will be after this. Anybody else having any other question? Okay, so these are all your data set. Third part is unstructured. Unstructured format is again no fixed format. Different files will be there. Example, audio files, video, common files formats are this. Then text file like Word document, text file format, images, signal, these are all comes under your unstructured. Majority of the data that is getting generated and available in the digital platform are unstructured. Okay, you look at around yourself, most of the data that you upload is either of text type in form of comment or posts that you do. You write some text around it, then you upload videos and images, right? So that's all, that's where you can categorize this data under unstructured format. Okay, let's go back to our example. Now CSV will make sense to you. CSV stands for full form, guys. What is CSV full form? CSV's full form is comma separated values. Okay. All right. So now let's look at. So we have seen how data science can be applied into different sectors. Now let's see some of the challenges. So let's look. So first of all is the data quality. The quality of the data is mostly is not up to the set of standards. You will usually come across the data which are having following issues. Data issue is the most important issue here. What are the type of issues you will find? I mean, these are called as your raw data. And the role of data scientist is before you go for like any of the process of either data analytics of any of the three, you have to prepare your data well. And that's where the things will be, you have to use the libraries and all. Data could be inconsistent, then inaccurate, incomplete, anomalies. Anomalies are like away from the regular trend. Okay, like this will be some data which are away from your regular trends. Far away from your regular trend or regular group. So data quality is not assured while providing it, while you collect it, that is not assured. You have to convert the data that you have taken. You take your data and then you convert the data into a set of format. Okay. Integration. So first challenge is data quality. Next is data integration. Data integration with several enterprise applications and system is a complex and pain tasking. What we do here is we particularly use the data and build various and we integrate it with your available enterprise level applications. Like maybe you wanted to integrate the available result in a existing web page. That could be one thing. That's again a new challenge. This is not part of data science, but what you have to do is you have to convert the data in a real application form. You can build this. Data is distributed into large clusters. Like suppose I wanted to make prediction on Excel sheet. Okay, my data scientist team has built the model and everything. Now, what my expectation is that I want the team to provide me some solutions so that the team of data engineers they can just use the application directly on their Excel and they can add it. Okay, like add-ins are there. We can do some add inserts and we can simply start using the application which will read the data in the raw form and will convert the data into a prediction or maybe into a clean format of the data. Okay, so that's the kind of application that we want from the team of data scientists, which we can do it with the help of some applications. I mean, some different type of applications which are available, some different type of cloud environment solutions that we can do, like a web applications. So ultimately, you can do it with the help of web applications part. Data is distributed into large clusters in HDFS. Now, what this HDFS is for? So this is not part of the, again, data science topic. This is related to big data. Okay. HDFS stands for Hadoop Distributed File System. For you, the understanding of HDFS should be that only one thing, that it is a storage. It provides you storage. Okay, like you have a database, RDBMS, which provides you the storage where you can store the data in a. How does the data get stored in the RDBMS? In a proper format, right? This can store any of the three files. Any of the three files include, any of the three dataset types include structured, unstructured, or it is semi-structured. All these three type of files we can save it in HDFS, and this storage is used in big data. When you study big data, then you study about this part. So as of now, just understand HDFS as a type of storage which can store all the three type of files that we have studied. All right. What about the RDBMS here? RDBMS is also providing the storage. What type of storage it will provide us? Anyone? RDBMS provides you which type of storage? Just studied. Give me some example for RDBMS. We're taken here, right? RDBMS example, MySQL, and the type of data that will store here is your structured data, right? The data available in a structured format is available under your RDBMS. Similar to RDBMS, which is one of the type of storage that stores the data, yes, correct, in a tabular format. Similarly, we have got NoSQL database as well. NoSQL, that is no structured. The difference between them, this stores the data in a row-wise format. This stores the data in a column-wise format. Stores data in a columnar format. This one is row-wise. This is column-wise storage. Example, MongoDB. MongoDB, HBase, two popular NoSQL databases. Again, this is not part of, the understanding of this is not important. As a data scientist, if you know about the queries, that's just an add-on, but not mandatory. What you should know about is the next part that we'll study. What will be the expectation that a data scientist should know? What these are providing here is the type of data sources which will be available to you when you are working in a real world environment. The data might be coming up from web applications, from the semi-structured format, from the structured format, and from the unstructured format sources. Correct? And they all will be stored inside HDFS. All this data will be available in your HDFS form, and then you will access these data from the HDFS to continue. All right, or maybe it depends upon organization. Sometimes the data will be coming up from some live sources as well. Okay, we will not go into that part much deep, just understand the challenges here. So challenges is data quality. Okay, so data might be inconsistent, duplicate entries will be there, missing values will be there, incomplete data will be there, anomalies will be there. We need to see the data quality, the problems of the data quality, and we need to set some standards in that. Then we have to integrate the data that you build, okay, the solution that you build with in a form of web application, so that other team members could also use it. All right. The challenges is how you can analyze the data from the cluster form like HDFS. Similarly, the problem of unstructured and semi-structured data, they are harder to analyze as compared to structured format, which is totally true. You can understand it. The data is, if it is available in an RDBMS form, that means the data is neat and clean. All right. Whereas in case of semi-structured, it will be a raw format data, and the possibility of having an inconsistent data is also there. Unstructured data, yes, unstructured data, we can read the text file, right? There are libraries for that as well. Like you can perform NLP with that, natural language processing. Okay, you can read the file by using text file again. You can read it directly with the help of text file. Okay, or by using pandas. Also, you can read the file library. So, possibilities there. Then images could be read by packages like OpenCV. So yes, you can read these files format as well. The good thing about the Python is, for every type of file, you are having various libraries. For every type of problem statement, you have the libraries available, so you don't have to write the things from the scratch. So welcome to Python here. Let's start with that. Let's try to discuss like what exactly you will be learning in this journey. So Python deals with each and every stage, and it includes at every stages of data analytics, and it includes these steps. So first of all, we have to study about the way or the method of acquiring the data. What is the meaning of acquiring it? You can download the data from the various sources. Okay, maybe the data is available in a URL form, right? And maybe the data is available in an HTML format. Data is available in an XML format. So various formats are there in case of data acquiring here, with the URL, HTML, XML. Alright. Now through these various sources, you can download the data, and then you can go through some different steps. Alright. So the point here is that we acquire the data, and then we try to acquire the data means we try to collect the data here. We try to collect the data here. All right. Next part here that we need to discuss is the data acquisition. So data acquisition is done. Now, how does we use the data acquisition, right? I mean, maybe the supportive library will be there. So one by one, remember that data acquisition or data acquire is part of data we can download from the things like Scrappy, How much slow we will do? I'm already slowed down, right? Now just watch here. How many slides we have studied? And how many hours it has been? So what we are writing here is the type of live packages, right? The packages are a Scrappy package, and the package that we are using here, the library that we use here, its work is to perform web scraping. You can also do here with the help of Beautiful Soup. Beautiful Soup. The purpose of these two libraries are to perform web scraping. What is web scraping in short is that we take the HTML data, like every web page is having an HTML records, right? So from that, my motive is to convert this HTML data into a meaningful site. Like for example, in that HTML, you will be having many records that we are looking for. So our motive is to scrap the records from the web page. That's what the acquire part is all about. So if we will go to the examples here, suppose I'll go to a particular, could be done through Beautiful Soup, or you can also go through the so here we will go to some website. Let's say I'll go to Amazon. Okay. And in this case, you can take any product. Let's say I'll go for a very good product of Amazon, which is Amazon's Fire Stick. Now, if I'll go to the Amazon Fire Stick here, any one of these products I take, just look at here. When we take this product, you go to the reviews, right? You go to the reviews here. What is this? I'm gonna go to the reviews here. All these I'll keep aside, and I'll just go to the reviews here. Okay, so these are the reviews. Now I wanted to find out the reviews here. Out of this, as a data scientist, my goal is to take these records, these details, like the title, the reviewer name, the comment or the review, and the rating. Similarly, the rating, again, name of the reviewer, the review, and on which date this review has been recorded. These are the type of information I can scrap from this website, right? What is the website part? So view page source. So that's my source. Excuse me. That's my source, which is called as my HTML page, right? That's what I wanted to tell you here through this example. That the role of acquire is to gather the data from various sources. So the source could be anything. Here the source I am talking about is an HTML source, and from that HTML I will only be taking only the information which I want. Okay, so that's the acquire part. It could be anything like, okay, one more part you can take. Suppose Okay, let me just make a quick search. Suppose health, health data from European Union, Wikipedia, or health ranking. Okay, healthcare in Europe. Now you see that in this case, there is a table in this case, right? There is a table. Now my goal is to extract out this information, only this table part. So how can I get only this table records from all these entire text? Again, same, through web scraping. Okay. So I talked about like the file format could be XML or HTML. These are the common file formats where the web scraping is applicable. Okay. So we will take this particular part. That's again done by two libraries. We will learn about Beautiful Soup. Alternative library is Scrappy. We will only learn about Beautiful Soup. Scrappy is not part of the syllabus. Okay, after you collected the data, we go for the next step, which is called as data wrangling. After we go into the next part, which is called as data wrangling is done by a very important library, which is called as Pandas. Pandas library. The role of Pandas library is to read the data in a format which is called as data frame, and after that it uses its powerful functions. So you convert your data into a new format called as data frame. We will study about this. And the role of the data frame, why we convert it? Because that will provide you a powerful set of functions. You'll get a lot of inbuilt functions. I mean, that's why we are using the pandas, okay? And what this data frame is, this is your 2D format, again rows and columns. So it converts the various raw format data, semi-structured format, okay, semi-structured, even your text type of data you can read and convert directly them into a 2D set. 2D is rows and columns. Okay, so you will convert here the data into rows and columns. Why we convert into data frame? Because it then can help you to access the various functions. So when we take the session of data wrangling using pandas, you will learn about it. That there are a lot of powerful functions that is inbuilt and provided to us, and we can use it for our data preparation. Okay, as you know, data wrangling is what? What is data wrangling means? This is about, what is the meaning of data wrangling? That you convert your raw data, which is having issues like data inconsistency. So in order to handle issues like data inconsistency, then duplicate records, missing value, anomalies, we use these type of data, we clean the data, and that's where the pandas will be super useful. That's where the pandas will be super useful, that it will convert your issues of the data quite well, with the help of, first, it will convert your various different type of format into a data frame format, and then by through the data format you will get your functions right, which is called as your various functions related to pandas, and using pandas you can perform the treatment of the data. You can treat about the data inconsistency, missing values, anomalies, duplicates, etc. Next part is exploration. Next part is exploration part. Okay, so explore means you are performing here. It's called as actually exploratory data analysis, EDA. There will be a topic named as EDA called as exploratory data analysis. Nothing. You take the data, the clean data, and you perform the analysis on it. What you do here, you use a library like matplotlib, and you can call this as a simple word which is called as data visualization. Explore is nothing but it is a data visualization. Shall I remove these part? If you wanted to take the screenshot, please take it so that I can remove it. And if you want to ask anything about any of these three parts, you can ask it again. If you wanted to take the screenshot, do it right now because I need to remove and empty some space here on the left hand side. Right hand side will be still there. And if you wanted to ask anything about acquire, wrangling, and explore, please ask it. For visualization, we can use matplotlib as well as no. SciPy is not used for visualization. SciPy is more of a statistical term. I'm just removing it. So exploration is data visualization. Now the packages are, for data visualization, the packages are matplotlib. Packages are matplotlib. Other packages that are used for data visualization is Seaborn. Seaborn. This is wrong. These two are having maximum uses. Other packages are also there. Okay, next, model. Model is particularly, now you see that model is not created by NumPy, okay? Model is created by scikit-learn, okay? And visualization, you can do it just visualization, like interactive visualization. You can do it with the help of Plotly, okay? These are for like interactive plots. You can also use things like your business intelligence tools, which could be like Tableau. At industrial level, these are used, all right, Power BI, correct. So many tools are there nowadays that you can use to perform a good visualization environment. Tableau you can use, Power BI you can use. For us, I will be using only these two parts majority of the time. One example I'll take it on Plotly as well. Plotly is usually used for only plot and interactive plots. Model part, this is your machine learning section. So you'll study about this in machine learning. We will learn about scikit-learn package. Okay, we will learn about the scikit-learn package. The point is that we will not learn about the modeling. Definitely we will not learn about the model part. Model part you will cover in your machine learning section, not now. Alright? That's where this package is used. Scikit-learn. Scikit-learn is used for majorly 3-4 purposes are there for scikit-learn. I'll go to my whiteboard. And let me tell you here the packages which I can't write there, okay? So very large number of packages. One is NumPy. NumPy is used full form numerical Python. Its main purpose is to create matrix n-dimensional array. N-dimensional array, and you perform mathematical operations between them. So you create your NumPy array, which will be an ND array that you will create, and you use this array to perform some numerical analysis. Its main purpose is to have your idea about how does it work. We'll have a separate discussion about NumPy, so just keep it as a term right now. When we will discuss it, you will understand it much more better. Right now, treat NumPy as a library and a short note on it that what is NumPy will do. We will discuss about what is NumPy and all as we will progress ahead. So NumPy will be a numerical data, okay? You will use your numerical arrays, ND array, n-dimensional means could be of any size, and you will use this to perform some mathematical operations, and that's what the main purpose of this library is. This is for basic analysis, basic purpose, basic learning purpose. Okay. Then after this you learn about pandas and all the heavy stuff. The last library that you have to learn is scikit-learn. Scikit-learn again, it is another library that we have from Python. Its main purpose is to do few of the important details about the data, okay? So first what you do with the scikit-learn library is that you can obviously use it for data processing. Use this library for data processing part. That's where we will use it in data science. That will be the data science uses, okay? Next part, which we will not discuss, is your using scikit-learn for machine learning. This is one of those packages which provide us a humongous list of all the packages which a user will require. A user will require to perform. Okay, to create a machine learning algorithm, we use scikit-learn. So that's the next level thing. Let's not discuss about this part, but yes, we will discuss about how scikit-learn could be used for your data processing stuff. Okay, so again, how to convert the data, we will study about it in using the scikit-learn library. Okay, so I think all the libraries are clear to you. This is very important stuff because that will be the thing that we will learn in our lectures, starting from Python, then NumPy, then pandas, and so on. Okay, NumPy should have been not in the place of model, of course, because NumPy is just for basic stuff. You can use it for creating arrays, and it again provides you various inbuilt functions which will be used for your array calculations. All right. SciPy package. I've not discussed about that. So SciPy package is used for your statistical analysis. Okay. Full form is, yes, correct. Full form is scientific Python. Full form is scientific Python. And its main purpose is to provide you the library, the functions again, that will help you to perform the statistical analysis on data, right? Like some sort of your wanted to perform some hypothesis testing, okay, or some sort of a calculations. You can also use it to generate data, etc. That's the solution. Okay. All right. So these are all your packages, and ML algorithms. Few of them comes under the SciPy as well. Like very few of them. Yes, there are few algorithms such in which comes under SciPy as well, but maximum of them still there at Scikit. Okay. So hopefully everybody has understood it. Please respond in the chat with your questions, or if you have no queries, then you can respond with. Did you all got it till here? You can respond yes in the chat. If you have understood till here, just respond yes in the chat. That was all about it. Bouquet is library for visualization, correct? For interactive plots, Plotly and Bouquet libraries are used, not SciPy. What is the difference between explore and visualize? So basically, when exploration and visualization could be like, see, visualization could be for anything. Like, I wanted to display a picture. Okay, I wanted to show an image. That is also visualization, right? But if I wanted to now visualize or create a plot of data to explore the insights. That will be called as your EDA. Suppose we are doing some sort of having details about various makers of the okay, let's say I have a movie records. Okay, year-wise record will be there. Year-wise record will be available there. Using this movie records, year-wise details are there, like which movie has released in which genres and which year. I wanted to know that in which year, you have got maximum release under genre in a genre of which one? Comedy. I wanted to know that. That's called as EDA. Okay. So visualization could be anything that you are converting into a view type, so that you can display it. This will be a simple display of image, which is not giving you any information. But exploration is, it will give you information about the data. Alright. So you can convert this record into a bar chart for year-wise under a different genres. You can use a bar chart and you can get the answer. Explore can be for anything, not necessarily. I mean, exploration is what? It's particularly you are taking the data and you are applying some nice statistics onto it, or some count, some sort of an analysis will be done in short. And then you will convert that into visualization. Okay, so done. Hey, what happened, Ishaq? I have just responded, right? The same question was asked by somebody else, and I just gave the same example. Just read it, what we have written here. Same question was asked by somebody else just before this. What is visualization? Visualization is simple display of anything which will not give you any good insight about the data. And what is your exploration part? Exploration is you take some insight from the data and then you convert them into a plot. Like example was, we have got the year-wise movie record under different genres. So you can convert this into a nice bar plot, year-wise and under different genres, to find the answer for in which year we have got the maximum release of the movie, maximum count of the movie under genres equals to comedy. So you can filter the record, convert them into bar chart. That will be EDA. Whereas visualization could be anything. Prajwal. So Prajwal, the point is this session is related to data science, and the previous one, the older one that you are talking about, that was older course. This is an updated course. So that's why the duration has been reduced now to just 8 days now. Earlier course was much more lengthier. The machine learning part is no more a part of this. Somebody was asking about machine learning. So course duration has been reduced. Anyway, all right, Python tools and technologies, next part. These part are important again. I think I have already give you enough about it. So quickly discussion, NumPy or numerical Python is the fundamental package for your scientific computation. SciPy, which is your core scientific computing libraries. And as I said, the main purpose of SciPy is to apply scientific mathematical packages, use them, and explore the data. Also, this is used to generate the data as well, which are more scientific type, and it is a one-stop solution for all your statistical needs. The SciPy I'm talking about. This is one-stop solution for all your statistical functions are available here, which you can use directly by importing the SciPy library. Matplotlib, the simple plots. NumPy, the creating the arrays here and using the array and applying scientific computation to it. And we know about the pandas and all as well. Benefits of using Python. Now, the most important benefit of Python is it is easy to learn. It is easy to learn. It is open source. Open source means you can use the package, use Python package, and can customize it. Why you can customize? Because it is free. It's open. You can use it as a license tool, and you can convert it into a. You can convert the libraries and packages, all of them, in fact, NumPy or SciPy or scikit-learn, everything is open source. Okay? Open source means free licensed, and its source code is also freely available. Samik Sarkar, please take care of it. I've been already declining it many a time. This is free license. Apart from this, let us talk about that. The packages, Python is okay, free licensed. Python's source code is freely available. So you can make changes, you can customize it as per your own use cases. It is efficient and multi-platform support. Okay, so you can run it in multiple platforms. Python is an open source programming language. It is readily available, easy to install and get started. It has got large presence of it is also has a large presence of open source community and software development support. Python and its tool enjoy multi-platform support. Application developed with Python integrate easily with other ecosystems, other enterprise systems and applications quite easily. So that's where again we have got the advantage. We got the huge collection of libraries and functions. It has got the big open source community. Having a big source of community helps you in solving complex problems just like that, just easily because of the presence of the libraries and discussions platform. Python and its tool enjoy multiple platform support. Okay, and whatever the application that you develop in Python, this can be integrated. There are a lot of tools, platform and product in the market from the different vendors. They offer great support. Third party tools are there. Like you can think about it. The presence of Anaconda. Anaconda is a distribution which contains all these packages inbuilt. It is a one-stop solution. All right. Python and its libraries create unique combination for data science because of all these benefits, and it is usually popular among the all your learners and enthusiasts. The library that you can use or you can install is Anaconda software. Why only Python is best? We don't have these things what has been written here in other languages. It is not easy to learn. It is not open source. Not every software. It is not the most biggest advantage of using Python is we are having a lot of libraries which are not available in the mentioned two at least. The competitor of Python is R. In data science. In data science, R programming is the competitor, not Python and C++. They are very far behind. R is also open source. That's why I said competitor, right? Somebody is asking which one is easy. Whatever your mind understands better, that is easy for you. Everything else is tough. That's how I understand the things. Whatever we learn, if A for apple might be easy for you in the nursery, but for somebody, it might have taken two more classes to understand that A is for apple and B is for ball. It's like that only. Everything that you learn. No, excuse me. Alright, so here we go to our next step, which is, so this is the last part. Python is supported by well-established data platforms and processing frameworks. Can we just ignore him? Okay, please pay attention here. So here we go, we are having the data. Python is supported by well-established data platforms and processing frameworks that help it to analyze data in a simple and efficient way. Enterprise data, big data platforms. So we are having things like, see, this is related to basically big data part. We can ignore this part. Just understand that at certain point in the big data, we need the support of these packages and all. Okay, cut short, like these are just related to the big data topics. And what we need here is that we are having, can we just ignore him, Mr. Ram? Please pay attention here. So use Python, use of Python in big data is that is just like any programming language, and perform data analysis and processing. Our purpose is to perform the data analysis and processing. So here our tool is, okay, now where this Python could be integrated. This can be integrated with let's use this Python. So this will be used with a tool like Spark. Did you see the Spark part? That's what the tool is used. Its main purpose is to integrate this with our Spark topic, Spark tool. That's where the Python programming could be integrated, and then you can process big data. Just like the way we use a short range of the data using pandas and all. Similarly, just a second, guys. All right, so let's discuss here. I said like, just give me a minute. Shara. So it is essential to connect to these big data platforms to process big data in Python. Not compulsory, always it is important to connect with the Python, but where if I have to place Python in the use case of big data, this is where it will be used along with Spark. I mean, that's just a topic, so you can ignore this as well, not compulsory. Because without knowing big data, this will not make any sense. But yes, as a data scientist, sometimes you have to work in the big data as well. For that, obviously, you should have a separate course. We have a separate course. So let's go ahead. That's how the things are. Okay, now let us discuss here about the data scientist part. So quite an easy part just to brush up yourself so that you can give the answer. Answer is D. All of the above. Acquire the data, ask the right questions, and perform the data wrangling and data visualization. Okay. Next question, next part. D is the correct answer for this. Simple. All right. Now read this problem, read this question, and try to answer the second question now. The search engine's autocomplete feature identifies unique and verifiable users who search for particular keyword or phrase to dash select all that apply. There will be two answers. There could be more than two answers as well. There could be two or three answers. So please read then. There could be more than one answer as well. In this case, there will be more than one answer. So please read properly and then give the answer. So first of all, we are talking about autocomplete feature. So this example was just taken. Identifies unique and verifiable users. So on the basis of unique and verifiable users, we build the query volume and we also tag the location to the query. That's it. Answer is A, sorry, answer is B and C. Question. Unique and verifiable users. Only B and C. That's why I said like if you will read the question then only you will be able to answer. Anyway, see when I was taking the topic of this I said like two things, right? That verifiable users, they are used for generating query volume and the geographical locations. These are the two parts which was dependent on users. Others are independent from these. Alright, so B and C are the correct answer in this case. Next, what is the sequence flow of analysis in data science? Like the way we just read, try to answer this question. Very simple. Starts from it starts from data acquisition, which is your data acquire, then data wrangling, then you perform the exploration, then modeling, and then model visualization part. So answer is C. That's it. First lesson ends here. Okay, now we will discuss about the installation part. So let's do the installation. No, no, class is not over. Hello. Wait. Before you start celebration. But you started celebrating. Okay, let's say I'll just send you here. Okay, very important thing. Please save it somewhere. Please save it somewhere. Community link. Community link. This is where no community link. Google Drive is not used now. In the community link, you will be pasting your queries and questions. Also, as I said, I will be pasting here if any material I have to share. So first of all, we have to perform the installation of Anaconda software. Those who have already finished, that's good. Let me discuss with others, those who have not finished yet. So let's start with that. How many of you are new to Python or not studied Python anywhere? Just wanted to take a poll quickly. How many of you have not studied Python? Even the basic. See, if you know till functions, our work will be over. Those who already have the knowledge, that's great for you. There are plenty of them who doesn't know about the Python. So we'll have a quick recap about the Python here. If you know about it, it is okay. Please follow the link. Those who haven't installed Anaconda, how many of you haven't installed Anaconda or does not know about it? So those who don't know, let's do it. So I have shared your link. You can scroll down. Please scroll it down. In this case, you will find Anaconda installers. I'm sharing you the link again. Okay, please stop sharing anything in the chat. I want a complete silence in the chat now. Please make a silence in the chat. Let me discuss some important thing. So all the attendees, those who already have installed Anaconda, that's good. Now I want complete silence in the chat. Please follow this link. Nobody will be responding right now. Please scroll it down. So when you will open the link, you will see something like this. Scroll it down and make sure that you select the correct one. If you are on Windows, 64-bit. If you are on Mac, 64-bit graphical installers. I think very rare will be there, somebody will be on Linux. So install first or second. (64-bit) graphical installer. It depends upon the software. Basically you are having the graphical one will be working on both the cases. It is dependent upon your OS, doesn't depend upon the processor, right? So look for your processor part, sorry, look for your OS and then decide which one you will choose. Installation download done. Now after your download will be finished, you can follow some notes here. Okay, let me give you some, let me upload that note. You can follow that from the documentation, the community link as well. As I said, guys, please make the chat less active right now. Windows 10 64-bit, correct. Windows 10, 11, 8, all these are 64-bit. Now, a small guidance before you perform the installation. So just have a look on this. This is an old setup. Most probably this is how it will look like when you will double click on the software. It will ask you to do the next. Then you will click on I agree. I'll highly recommend you to provide here the all users permission. So click on all users and do the next. It will require admin privilege. If you are using in a laptop where you are not the admin, so you can go for just me. That is also okay. Then you will do next. Okay, register Anaconda as a system Python 3.7 or whatever, Python 3.8, 3.9, whatever you are getting, that you have to register. This option might be disabled, might not give you the option to click on add Anaconda to system path. You can check it. If it is allowing you to click on this, it's okay. Otherwise, you can skip this part. No problem. And then simple, click on install. So this is a step that you can follow and you can make your Anaconda software ready. You can make your Anaconda software ready. Visual Studio you can use, but you have to keep on installing the packages as well, time to time. There is no foundation. So installation will take near about 10 to 15 minutes depending upon your processor to install it. Okay, now if you still not able to follow the installation, community link questions depend upon if it is on weekend, then you will get frequent reply because I am the one who will be getting the responses, giving you the responses. Use desktop, not your iPad or all something. Okay, next. Yeah, let me share this material for everybody. Give me a second now. So now we are into the end part. Let me just share here the installation guide, and I'll also share today's notes as well. So you can just go through this if you wanted to install. So please make sure that you all install it. Otherwise, then you have to use your LMS part. Otherwise, you have to use your LMS part. Then there will be no part here. Notes also will be uploaded here. I'll upload the notes after the end of the lecture, not now. Maybe weekly wise. So let me guide you once again, because I don't want any hiccups tomorrow that this is not done or that is not done. Okay, I have been having some experiences in previous batch. Just wanted to make sure that your lab should be ready. So click on launch lab and make sure that your lab part is ready, so that tomorrow straightforward I will start with the topics. So participants, just please see here that when you open the lab, you see this option, you select the kernel, just keep your kernel as Python 3, and you can click on select option. So you see here, this is how your option look like in practice labs. Kernel option is Python 3, then click on select. Once you click on select, and then you can pass here. See, for Python, you can use Google Colab, but then again, for data science, Google Colab will be fine. Okay, but then you will not able to use the data set part. All right, so you will write here the data. Yeah, you have to first log in into this. All right, so both of these things are clear to everybody. Both of these are clear to everybody. Can I have a quick yes in the chat? So either you do it through the Python or you do it through the Anaconda. That is up to you now. All right, fine. But yes, one important warning. If you are using here this, yeah, you can use this in mobile anywhere. This lab will be accessible everywhere. But I don't know your mobile screen will be enough to see the things or enough to type the things or not. That is up to you. What I was saying is that see, this is also counting the clock. So make sure that when you are finished, please make sure that you shut down here. Click on file and then you shut down here. All right, this is important. Otherwise, the clock will keep on running for next half an hour, and that many hours will be reduced. Okay, that's it. Yes, at the beginning you will get only 50 hours. You can later extend it, but as I said, you already have the this Anaconda, and also you won't require that much lab part. But yes, total duration is 50 hours. The course duration will be not more than 30 hours. All right, then thank you so much everybody for your participation. I'm done for today's lecture. Tomorrow we'll start with Python. Okay, we'll try to finish Python programming, and so you can brush up. So we'll take a quick Python session, and we will also discuss about the if Python will be over, then we will be into the NumPy part. So Python and NumPy are the first two sessions that we will be trying to discuss. There is no requirement of before study, but if you will do it, it will be good. For today's session, please copy this community link and save it somewhere. Please copy this community link and save it so that you can access the materials. Just bookmark it. Just bookmark it. Okay, or copy this link and save it. Shubham, it will take some time to install Anaconda. So you just leave it as it is. Automatically it will get installed. That's all. You can share the screenshot if you face some issues in the same community link. I'm talking to Shubham. Alright, that's it for the day. You all can leave now. Thank you all. You can click on file and you can stop, shut down, click on file, click on shut down. Thank you all, bye bye.
Thanks for the wonderful session, Amit sir. Amit sir, regarding the issue with the learner, we have taken care of that. From tomorrow onwards, you will be getting any disturbance from people. I hope everyone enjoyed today's session. I have already shared a feedback link for today's session. Please do provide a valuable feedback. Once we wind up the session, it will also automatically pop up in your default browser. If you like the session right now, if it is your side, please provide a valuable comment. Based on the comments you have provided, we'll be doing in the upcoming sessions. If you guys have any other concerns, you can please put in the chat. If no more queries, we'll wind up the session for today. download the LDS link. Okay, guys, as there are no queries, we'll wind up the session for today. We'll meet you on tomorrow's session. Thank you all. Hello. Okay, thank you all. We'll wind up the session for today. Take care or bye. We'll meet you all in tomorrow's session. you.